Hello, I'm Theon, a doctor in the UK with over 15 years experience. I wanted to share this great graphic by Dr. Andrea Love, immunologist and microbiologist, because I think it highlights that correlation does not equal causation. Now, research is only as good as the question you've asked and the way that you've tried to answer it. So that's looking at the way you've measured outcomes in your data. And actually, statistics and data can be manipulated to really answer any question you want. Research can be influenced by lots of different things, and that's why we pay attention to who's funding the studies, for example, and if there's a drug company who might have an ulterior motive because they might want to sell their drug. Because of this, it's important for researchers to be transparent about any conflicts of interest and who they're working for. Because of difficulties funding big studies, there are a lot of questions that go unanswered in research, and so we always have to assume there are things that we don't know. The current climate of science misinformation, this point about correlation versus causation is really important to get your head around so that you can spot bad science when you see it. For instance, from this graphic, we can see that organic food sales and autism seem to have a relationship in terms of as organic food sales increase, our autism diagnoses also increase. Does that mean that organic food causes autism? I would say we just don't know. The truth is there are lots of things, some we know, some we don't know, that are probably influencing this observed relationship between autism and organic food sales. So I think it's safe to say at this point that this probably isn't a clear picture. We call those things confounding factors, and I like to think of them as confusing factors because they can add an element of confusion into the result of that study and that relationship between the two things you were studying. Now, it is possible to do some fancy calculations and statistical analyses to take into account those confounding factors on the outcome of a study. But first, we need to know what those confounding factors might be. So that requires us to know a bit about the thing we're studying before we do the research, and we need to measure some of those confounding variables. If we don't measure them from the beginning, then we won't have any data on them, so we won't be able to take them into account. We can think about those confounding factors afterwards, but that's a bit more tricky because it's still an unknown, really. We can just make some assumptions. In this case, it seems plausible and quite likely that people who have more money might be more likely to buy organic foods, and also the same people with more money might be able to afford and think about getting an autism diagnosis for themselves or their children.